So, 1.6 trig functions. Stop talking. Stop talking. Why are we talking? No reason. This is rhetorical. Should not be talking. Shouldn't ask you this 5 times. If you're talking, you know you're talking. You know that when I put on participation grades, your grade's not going to be 100%. All right, so 1.6, here we go. Trig functions. Radian measure on a unit circle. So we know how to convert. If you're going from degrees to radians, you multiply by pi over 180. So if you have however many degrees, 18 degrees, you're multiplying by, well, the degrees will be on bottom, so pi over 180. If you're wanting to go from radians to degree, well, if you have 3 pi over 2, and you want to know how many degrees, well, pi's on top, so you know pi will be on bottom. Or you could be like, cool, 4, radius 2 degrees, 180 over pi. I just look at what I want to get to. I want to go to degrees. Degrees has to be on top. We know 180 is equal to pi, so that's our conversion factor. Arc length, hold on, is arc length after this? Okay. Yeah. So review the unit circle. Make sure you know how to find the trig and inverse trig values based on the unit circle. That's a fun one. So on the unit circle, we know that sine of theta corresponds to your y value. Cosine of theta corresponds to your x value. We also remember all students take calculus, so in the first quadrant, everything's positive. In the second quadrant, only sine is positive. Third quadrant, tangent's positive. Fourth quadrant, only cosine is positive. So let's go through the easiest ones first. Hopefully this won't take too long. We'll go through the first. What? Yeah, all students take calculus. You guys finally are the all students. You guys are the all students taking calculus. All right. So, first one. 0 degrees is the same as 0 radians. Guess what? This is also the same thing as 360 degrees, and this is also 2 pi radians. What are sine and cosine of 0 degrees? Do we remember? Also, I already told you 0 and 1, which is which?
1 is x. 0 is y and
Cosine sine. No.
Yeah.
So, surprise, remember I said cosine's x and sine is y? Yeah, so x is your cosine. Cool, the point is 1, 0. Okay, how about this next one, which is 30 degrees? How many radians is this?
Pi over 2.
Pi over 6. Close, 30 degrees. And if we remember our 30, 60, 90 triangle. Close, that's for 45 degrees. We're at 3 over 2. And 1/2.
Do we need to like memorize those again?
Yeah. I mean, you should know it.
I never learned it in the first place.
That's awkward. This is literally what you should know from Algebra 2.
Yeah.
Algebra 2?
Yeah.
Yes.
Oh, yeah.
No, you keep the hats on for the 4th time. You do not take the hats off yet. Okay. So just a quick reminder of our special triangles.
Do we have to know this whole thing? Or like, you know how some people do that? No, but you know how some people do like charts and stuff like that? Are you gonna like test us on the actual like diagram?
I probably should. I should do that.
But like, if there's another way that like, I was curious because last year like I learned it in different ways.
Yeah, I learned the way through the triangles, like by memorizing the triangles.
Yeah, so I'm bringing this up right now. So if I have a 30-degree angle and I have a 60, just a reminder, 90 across from 30 is just going to be your short side. Across the hypotenuse is 2 times your short side. And across from 60 is root 3 times your short side. So if I'm taking, let's see, x is cosine. Cosine of 30 degrees adjacent over hypotenuse. That's x root 3 over 2x. So literally root 3 over 2. Do you see this? And then when I take sine, sine is your y. Sine, opposite over hypotenuse, x over 2x. 1 over 2, 1/2. Surprise, I don't know if you guys saw this that I left up while you were taking your quiz.
There used to be that one there too.
You know, I didn't say anything, I just left it there. you know.
Oh, that's so nice.
If you are, if you observe your surroundings, if you have spatial awareness, the world tends to be a better place. So I don't say anything. I just might leave something up accidentally and let you use it. Cool. Okay, so let's review our other special triangle, which is 45, 45, 90. 45, 45, 90. So I have leg, root 2. 45 degrees. What is this in radians? Pi over 4. Guess what? Cosine 45. Adjacent over hypotenuse. X over x root 2. Well, normally we say root 2 over 2. And guess what? Y is the exact same thing. If you know this first quadrant, the rest of them are the carbon copy, except for all students take calculus. The SIGN comes from all students take calculus. If you know your two special triangles and you know your first quadrant, pretty much going to be chill because our whole thing called reference angles. Okay, so 30, 40, next is 60 degrees. What is this as radians?
1.5.
Pi over 3, pi over 3.
And then it's 1/2.
Because if you think about it, pi is 180. 60 is a third of 180. So pi over 3 is a third of pi. Okay. So interesting. If I'm looking at 60 and I want cosine adjacent over hypotenuse, it's going to be x over 2x, which is a half. Literally, it's the opposite of 30 degrees. Perfect. And lastly, we have 90 degrees. This is equal to pi over 2. And what are the coordinates? 0, 1. Beautiful. So A, all of them were positive. Now let's go on to the second quadrant where I'm literally reflecting all these things across. So I want you to notice is if I count by 60s, all of them will have the same. So multiples of 60, oh my gosh. So 60, 120, they have the same reference angle. Do you remember the reference angles? Literally the angle from the x-axis to the terminal ray. Because if I would trace out this angle, that's right here, trace out 120 degrees, what I'm looking for, I'm going to erase these colors in just a second because it looks bad, but what I'm looking for, the reference angle, is between the x-axis and the terminal ray. Because this is a 60-degree reference angle, and this one is a 60-degree reference angle, they're going to have the same x, y coordinates, except different SIGNs, different signs, positive, negative. All right, so 120 degrees, that's just going to be 2 pi over 3. The coordinates, let's see, so 1/2, comma, square root 3 over 2. Then I look at all students, sign is positive, so only my y's are positive. So it's actually going to be negative 1/2, which makes sense. I have negative x here.
I have a question.
Yep.
When you're finding the coordinate, are you using the sine or the cosine?
Both.
Both. So the sine is y, so you would find the
X comma y corresponds to your cosine, comma sine.
already.
Okay. So let's see, next is our 135, which is 3 pi over 4. And it's just the same as the reflection across. So it's these same numbers, except x is negative. Same y. So literally, you know the first quadrant, you know the second quadrant, you're just changing all the x's to be negative. All right, so this is going to be 150, also known as 5 pi over 6. So where I had positive root 3 over 2, I have negative root 3 over 2, comma 1/2. And then I reach pi, which is 180 degrees. That's going to be negative 1, comma 0. So if I ask for cosine of pi, well, you know it's negative 1 because that's your x coordinate. Okay, we ready to go third quadrant? We're just counting. I don't know if you guys can tell, we're going 30, 60, 90, 120, 150, 180, 210. So I'm looking at 210 degrees. Oops, I did not mean to do that. Went too far. Okay, so this is going to be 210 degrees, which is 7 pi over 6. So it's exactly the same as 30 degrees in the first quadrant, except both are negative. So I have negative root 3 over 2, and I have negative 1/2. Next, I have 225 degrees. And once again, same, root 2 over 2. Root 2 over 2. It's just both of them are negative. So 225 degrees, 5 pi over 4, negative root 2 over 2. 210, so next is 240. It's going to be 4 pi over 3. It's the same as 60 degrees. The coordinates for 60 degrees, difference is both are negative because we're in the third quadrant where both sine and cosine are negative. So I have negative 1/2, negative root 3 over 2. And then I reach my 3 pi over 2, which is also 270 degrees. So 0, comma, negative 1. Let me pause here. Are we okay so far? Do we see the pattern emerging? Hopefully. Do you think you can fill in the rest of this yourself? Let's fill it in. I'm gonna like put the numbers on there, but I want you to try to fill it in. So for example, I want you guys to like see the pattern. Like these are all reference angles of 30 degrees. These ones are all reference angles of 45 degrees. And lastly, these are all the ones with reference angles of 60 degrees. So if I look at the pink, right, if I'm looking at the pink, it goes pi over 3, 2 pi over 3, and then of course you reach pi, which is 180, 4 pi over 3. The next one in our list is 5 pi over 3. Where'd it go? 5 pi over 3, which is, let's see, 60, so 300 degrees. And then it's going to have the same coordinates as 60. It's just, let's see, only cosine's positive, so that means only x is positive in this fourth quadrant. So it's 1/2, but then you have negative root 3 over 2, which makes sense. You're below the x-axis, y is negative. The green one, we're counting by 45s, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4. The last green is 7 pi over 4. So that's going to be 315 degrees. And it's going to be root 2 over 2, root 2 over 2. Difference is only y is negative in this last one. And then the blue here, just, I don't know, I'm a visual person. I want you to see it. I have pi over 6. If I keep counting by 30s, I reach 60, which is 2 pi over 6. Oh, same thing as pi over 3. And then I have 3 pi over 6, same thing as pi over 2. 4 pi over 6, same thing as 2 pi over 3. 5 pi over 6, I reach a reference angle of 30. 6 pi over 6, pi. 7 pi over 6, blue, it's highlighted, that's a reference angle 30. What is it, 7? 8 pi over 6, same thing as 4 pi over 3 right here. Let's see, 9 pi over 6, well that's just 3 pi over 2. 10 pi over 6, same thing as the 60 right here, 5 pi over 3. And then I end up with 11 pi over 6. Don't know if you guys remember doing this or not. 330.
I used to just see which one would not equal that number.
Exactly. It's the ones that you can't reduce. Yeah, is it negative?
Tangent is sine over cosine.
Yep. And in the third quadrant, if you have a negative over negative, it turns positive. That's why tangent is positive in the third quadrant. Cool. So I see where it says positive, negative. So literally you can like write what's positive and negative in each one, but we do all students take calculus, so that helps us know. Okay, little review. Evaluate each of the following without a calculator. Write exact answers. No decimals. So, pi over 3. Sine of pi over 3. Pi over 3, 60 degrees. Root 3 over 2. Cosine, 3 pi over 4. So we know this is one of the ones with 45 degrees, so I know it's going to be root 2 over 2. Question is positive or negative?
Should we be able to do
Negative.
this really fast like that? What if we need to draw a picture?
Um,
To do that or no? Why is it-
You should be able to go kind of quickly.
Okay.
Because I'm already halfway there.
So you don't want to, well, you should be able to, well, we're going to have more practice, but you should be able to, like,
Oh, can you give us
understand that, like, 3 pi over 4 is a 45 degree angle, right?
Yeah.
It's just, so you write root 2 over 2, and then you have to figure out positive or negative. So 3/4 a pi is in the second quadrant. Cosine's negative there, so put a negative. So at least for the quadrantals, remember the ones that lie on the quadrant axes, you should know. Shouldn't really have to draw anything. The 45 degree ones, we should be like pretty quick about getting, as long as you remember, like, okay, it's a 45, so no root 2 over 2 for cosine sine, and then figuring out the sign, the SIGN, positive, negative. What?
Like on this for cosine 3 pi over 4, it has like a point, so it's x and y.
Yeah, x is your cosine, y is your sine.
So like if you had like f, like cotangent, how would you know to do x?
Cotangent, so if you find tangent, you just take the reciprocal.
Yeah, but like you do the x or the y.
Right, so we can go on to the ones with like tangent, cotangent. You have a question?
Yeah, can you give us the rules for tangent? Oh, you just said you would. Never mind.
So for instance, tangent of pi, well, I know tangent is, you could say y over x, you also could say sine over cosine. I know sine of pi is 0, cosine of pi is 1, so this is just going to be 0. Sorry, it's -1. So it's just 0.
Isn't there a rule that says like 0 and then root radical for and
Yeah, there's this whole like chart.
yeah.
So tomorrow, well, I'm gonna give it today, but tomorrow, like, we're just gonna be doing like trig review mostly. We can go over the practice test. I'm hoping to finish this lesson today, and then just like doing that worksheet tomorrow, going through the practice test, etc., etc. Right? Is that tomorrow? It's Tuesday. See, I don't have you tomorrow. I have you Thursday. Okay, sine pi over 6. Pi over 6. That's gonna be a 30 degree reference angle. Right, the
For 3 over 2 comma. That's 1
What?
half.
Man.
yes. And then since we're in the second quadrant, all students, S, sign is positive.
But it's the opposite, 1.
So Shani, how did you figure this one out?
Well, you said it's like 30 degrees, right?
Mm-hmm.
So that one's on the 30 degree one, and I remember it was 3 over 2 comma 1 half, and then I remember sine is y.
So if you need, like at the top of your paper, so you can memorize it exactly. I think like half you guys have that. If you don't need to draw a triangle for every single one. You only need 2 triangles, 45, 45, 90, and 30, 60, 90. And if you have the rules, 30, 60, 90, we should be able to figure it out. X root 3, 2x, x root 2. So as long as you like quickly can see sine opposite over hypotenuse, 30 degrees opposite x over hypotenuse, 2x, so it's gonna be a half.
Wait, how did you do that?
So sine opposite over hypotenuse, sine of 30 opposite x over hypotenuse 2x, that's just 1 over 2.
And you knew it was 30 degrees.
Because 5 pi over 6, the reference angle is 30 degrees. Because whenever you see like blank pi over 6, if you can't reduce it, pi over 6 is 30. Yeah. half here. Let's see here. Okay. Next one, secant of 4 pi over 3. So, okay, you know, secant, whatever. If I want to rewrite this, make it a little easier for myself, this is going to be the same thing as 1 over cosine of 4 pi over 3.
Oh, okay.
And we know cosine of 4 pi over 3, so cosine 4 pi over 3. If you can see the axes in your head, 4 pi over 3, third quadrant, pi over 3, reference angle, 60 degrees. So I'm looking for cosine 60 degrees. Do we know cosine of 60 degrees?
In the third
So
quadrant.
1 over root 3 over 2.
It's
Close. So cosine 60 degrees. Cosine adjacent over hypotenuse. Cosine 60 degrees adjacent over hypotenuse.
root 3 over 2.
Cosine 60 degrees adjacent over hypotenuse. X over 2x. So this is what I mean when I say, like, if you don't remember, you could have that little triangle. I'm like, okay, I'll try to like slow it down a little bit so we really understand. So I see secant 4 pi over 3. Right away, no bueno. I don't know. I know sine and cosines only. And then going from them, I can get tangents using sine and cosine. I can get secant because it's the reciprocal. I can get cosecant because it's a reciprocal. So you really only need to know sine and cosines, which are x and y's. So secant 4 pi over 3, reciprocal, this is the same thing as 1 over cosine of 4 pi over 3. Okay, think where the angle 4 pi over 3 is. All right, 4 pi over 3. It's past pi and down about a third of the way. It's in the third quadrant. Okay, so it's pi over 3 further than 180. This reference angle is pi over 3. That's 60 degrees. Show me your up there.
Yeah.
Okay, so this is pi over 3. I want to know what's pi over 3. Pi over 3, 60 degrees, cosine 60 degrees. Cosine 60 degrees. Here's 60. Cosine adjacent over hypotenuse. X over 2x. So I'm going to replace cosine 4 pi over 3 with 1/2. So it's 1 over 1/2. Dividing by a fraction is the same as multiplying by the reciprocal. So instead of dividing by 1/2, I'm going to multiply by 2. So this is going to be 2, except, I did cosine of 60 degrees, not cosine of 4 pi over 3. So because it's in quadrant 3, students, take only tangents positive, so this will be negative.
How do you know it's in quadrant?
4 pi over 3 is further than pi, but less than 3 pi over 2. Yeah. So it's further than pi. It's like right here, third quadrant. All right, cotangent 5 pi over 4. Immediately, what does this yell? 45 degrees. 45 degrees. Something with 45 degrees.
Negative root 2.
So, getting closer. So,
1 over 2.
That's over y now,
180
so it's root
plus,
2 over 2 times root 2.
No, it's. Isn't it?
It's negative root 2 over 2 divided by
Over
root 2 over
negative
2.
2 over 2.
Oh,
So,
that's over root 2.
tangent is sine over cosine. So, cotangent is cosine of 5 pi over 4 over sine of 5 pi over 4. So, 5 pi over 4,
Oh, right.
it's basically a 45 degree angle over a 45 degree angle. Okay. So if you think about this, 5 pi over 4, it's right here. It's a 45 degree angle. All students take calculus. If tangent's positive here,
Negative.
guess what also is positive here? Cotangent. So this is negative root 2 over 2 over negative root 2 over 2.
1.
It's just 1. Aha. Whenever you have a 45 degree angle, tangent and cotangent will either be 1 or negative 1. Either sine and cosine have the same sign, SIGNs, or they have opposite. That's it. Cool. Cool. Okay. Cosine negative pi over 3, negative pi over 3. That's 60 degrees.
Root 3. Root 3 over 2.
If you don't remember, guess what? I have 2 triangles drawn, so I can just do it quickly. Cosine negative pi over 3. This is 60 degrees.
Yeah.
60 degrees. Okay. Cosine 60. Cosine 60. Adjacent over hypotenuse. X over 2x. So that's 1/2. And if you think about it, fourth quadrant. All students take calculus. C. Calculus. In the bottom fourth quadrant, cosine's positive. This is positive. Okay. So I want to like make it as visual as possible, but also we just gotta like keep going because you already know this. All right, tangent negative pi over 4 is 45 degrees. Huh. So this is literally a 45-degree angle. This is a 45-degree angle. In the fourth quadrant, what is the SIGN, positive, negative, of cosine? Positive. What's the SIGN of sine? Negative. So opposite signs, so it's going to be negative. Okay, cool. Cosecant of negative pi. This is the same thing as 1 over sine of pi. Wait, what's sine of pi? Remember, it's the y. What's the y of the coordinate pi? 0? Undefined. Awesome. Cotangent 2 pi over 3. Okay. So 2/3 the way to pi. Which quadrant are we in? 2. We're in the second quadrant. Okay. So let's see. Tangent is sine over cosine. So cotangent is cosine over sine.
1/2.
Cosine 2 pi over 3 over sine 2 pi over 3. What's cosine 2 pi over 3?
Negative radical 3 over 2.
Negative
Negative 1/2.
1/2 over rad 3 over 2. Either one of these would be acceptable. So we're in the second quadrant. We know cosine of 60 degrees is 1/2. This is about the 4th time we did on the page. But since we're to the left, right, we're in the negative x's, we're in the second quadrant, it's a negative cosine. But I'm above the x-axis, I'm in the second quadrant, I have a positive y, negative over positive. Notice that the 2's cancel out. Divide by the same number, negative 1 over root 3. You can radicalize it, whatever, rationalize, radicalize. Okay, so let's do example K. God, there's so many examples. 11 pi over 6. Immediately, okay, so when you like see what we're dividing by, it should like tell you which angle. Dividing by like something pi over 4, 45. Something pi over 3, 60. Something pi over 6, 30. Okay, so I'm looking at a 30-degree reference angle. If that like helps you solve it, there's multiple ways to roam. You just decide which way is easiest for you. Okay, secant is the reciprocal of cosine. Wait, what did you say? 1 over root 3 over 2. So this is the same thing as 2 over root 3. And let's see, is this the right SIGN, positive, negative?
Triangles messed up, so across from the 30 degrees
Is x. And across from 60 is x root 3.
but the x isn't helping it. I don't know.
What you could do, instead of x, guess what? You could put in a 1. 1. Just put in a 1. If x equals 1, x root 3 is just 1 times root 3. Here, if you put in a 1, that way it makes it a little easier. Yeah. I just put an x there because, oh, let's say your triangle is like 50 is the shortest, and you can like fill in all the rest. Because that's technically the rule that people use in geometry and algebra 2. Okay, we are in the fourth quadrant. All students take calculus. Cosine's positive in the fourth quadrant. That means secant's positive. We're solid here. Sine of 3 pi. 1, 2, 3. So, I'll do it on the board so you can see. So ready? 1, 2, 3. This is where 3 pi is. And once again, my coordinates are -1, 0. Sine is the y is 0, so this is just going to be 0. Perfect. Cotangent, 3 pi over 2. So that's literally this point right here, which is 0, -1. Question is, tangent is sine over cosine, so this is cosine over sine. Or you can think about this as x over y. 0 over -1 is 0. So in pre-calculus, we learned, like, oh, sine is y over r, the radius of our triangle. But same thing. And lastly, cosine of -pi over 2. Wait, -pi over 2 is literally 0, because that's my y. It's the same angle. So that's kind of cool. A little review of this guy goes around to here. This guy goes around to there. And it is equal to 0. Okay, so that's a lot of stuff. But we're not even close to being done. How exciting. I over-explained all the stuff we learned from pre-cal. Okay, let's keep going. Graphs of trig functions. You must be able to graph sine, cosine, tangent graphs by hand. If you're going to take AP because you're junior, whatever your choice, the graphs you'll be required to graph by hand in AP Calc will have at most 1 or 2 transformations. Cool. So remember our sick rap song of sine? 0, max, 0, min, 0. Okay, cool. So keep in mind, domain, the x, it just keeps oscillating forever. Domain's all real numbers. What? It was before you came.
I didn't say anything.
Oh.
I was just
You said what? You said what?
Yeah.
Oh.
What?
Well, I mean, it was just last year. You were in my class last year. Nah, we had a rap beat. They sang it. 0, max, 0, min, 0. Notice, what is this noise? I'm trying to go over this. This should be review. If you have a question, raise your hand. Let's focus, all right? Hopefully at least for 2 seconds. That's all I want. Range, it keeps oscillating between positive and -1. And this is, of course, for the regular y equals sine x function. If I put a 3 here, I am stretching it out. That's the amplitude, but we're not doing that yet. Not yet. Okay. The period, every 2 pi, it does 1 complete cycle. Right? I can stretch the cycle and et cetera, but right now we're only focusing on the general. And then cosine starts at max, 0, min, 0, max. It's a little swoosh. That's it. Once again, domain, same domain, all real numbers, -infinity to infinity, goes on forever, keeps going in between -1, +1, it just is bounded, and then every 2 pi it repeats. And then tangent, because if you think about it, when we do sine over cosine, there'll be times where we have tangent at 0, and sometimes where it's undefined. So undefined means vertical asymptote. So we notice every at 90 degrees and at 3 pi over 2, right? 90 and 270, that's where tangent is undefined because that's where cosine 0. So that's where we have asymptotes. So our asymptotes happen whenever cosine is 0. So if you think about, there's places where cosine 0, that's where the asymptotes are for tangent. So the domain, x cannot equal multiples of 90 degrees or multiples of 270. Otherwise, the range, you can see it goes to infinity in both directions, and every pi it repeats. Okay. Transformations of trig graphs. So this A is the amplitude. That's how much you can shrink it or crush it, stretch or shrink. One thing I should probably talk about, sorry, let me go up for a second. The cosine is an even function. What does this mean? If you guys ever been to a child's museum or whatever where there's a mirror and you put it up and you can see your face reflected across and it's symmetric? Even means symmetric. If I put a mirror right here, this is reflected across. Versus odd means it's not. It means I had to rotate it like 180 degrees. It's not perfectly symmetric across. That's what odd means. So if I took this right here,
So even in odd, it's referring to reflection over the y-axis?
yes.
Okay.
And guess what? This guy is odd as well. Because even means you only reflect it across the y. If I wanted an odd, it's literally rotated 180 degrees. So if I would take the sine function, rotate 180 degrees, like that's what the left side would look like. Okay. Okay. So this is the general function we used last year. So if you're ever adding something at the end, you're literally taking the whole graph, shifting it up and down. That's the D is super easy to figure out. The A is also way easier to figure out. Normally, sine goes between -1 and 1. So that's a difference of 2, right? From -1 to 1, that's a height of 2, but amplitude is only half of the total distance from your bottom to the top, right? Amplitude is like the middle. How the distance from the middle to the top or the middle to the bottom. So if you see sine is going from +5 to -5, you'd see the amplitude's 5 instead of 1. If you want the period, how long it takes you one complete cycle, it's 2 pi over absolute value of b. So this is your b right here. And then your horizontal shift is the c, and depending on which function you're looking at, what was I going to say? Depending on which of the 6 trig functions you're looking at, you can remember how we did those inequality signs to figure out which way it's going now? Cool. Okay, don't worry, we'll do it again. All right, y equals 2 cosine x. Determine domain, range, sketch one period of the function. So if you have to graph, even if it's sketching, please use graph paper. I'm not going to take it off for the first, your first homework that I'm grading. It's because I was way lax last year, but this is also calculus. So this is a step up, so I'm going to be a step harder. But domain, what's the domain of cosine? All real numbers. So -infinity to infinity, and then what will the range be? Including, right? So we're going to hit -2 and 2. So cosine starts at the max. Here we're stretching everything up by a factor of 2. And then I go to 0, min, which is at -2, 0, back to my max. So keep in mind, normally our function for cosine looks like this. This is normally cosine of x, but we can see we're literally stretching it. We're pulling it vertically. We're stretching it by a factor of 2. So as I said, it will be 1 or 2 transformations. I'm not going to be the devil reincarnated like I was last year, where I gave you 5 things at once. That was crazy. It was, you can agree. Oh, well, that was something else. Okay. All right, we're going to do the sign before we sign off for the day. Groans, groany groans. Y equals -sine x. So sine, you start at 0, and normally it's 0 max, 0 min, but we are flipping over the x. So instead of going to max,
0 min, 0 min.
I'm gonna go down to my min, and then 0, and then reach my max, and then 0. Whoa, you're in such a hurry.
Oh, that's beautiful.
So normally it's reflected. All right, so we'll stop here for the day. We'll finish the rest tomorrow, and then we will go over more stuff, etc., etc.